Good morning, friends. Welcome to Water Resources Engineering class. So, in today's lecture, we continue with the groundwater hydrology, and in that groundwater hydrology, today we deal with this part of the groundwater hydrology. So, this is all we have already mentioned to you at the beginning of this unit itself. So, the main focus of this lecture is classification of wells, classification of open wells, yield from an open well, then what do you mean by constant pumping test, what do you mean by recuperation test, and some problems related to it. So, in this mainly the focus is on the types of wells. Basically, in that there are two types of wells. One is open wells, the other one is tube wells. So, today's complete lecture is focused on open wells. That is our focus actually. So, now you know what is a well. A well is nothing but a hole that is being made actually vertically into the ground in order to extract or in order to bring out the groundwater to the surface. That is basically the objective of any well construction which we will make it. So, some of them may be depending upon the need. So, we can classify them as one is open wells, the other one is tube wells. So, fundamentally what is the difference between these open wells and the tube wells is open wells means large in diameter. Generally, open well means very large in diameter. Generally, the diameter also varies from 1 meter to 10 meters actually, very large diameter actually. So, that is one thing, first thing. Second thing is it cannot extract from very deep. It extracts water only from a what you call it as restricted levels. So that means generally what depth we will go is now the depth at which we will go is maximum is 40 feet, 50 feet maximum, starting from 10 feet to 50 feet, that which we will go for generally the open wells depth actually. And the yield of an open well, the discharge from an open well is also not much. It is also very little actually. The discharge is maximum, many of the cases it is only maximum is 20 meter cube per hour or less. That is what the discharge. So, three characteristics I mentioned for the open well. One is the diameter is large. So, the diameter is 1 meter to 10 meters. Second one is the depth is also not much actually. It may vary from 2 meters to 20 meters. That is second thing actually. And third one is the discharge from the open well is maximum is 20 meter cube per hour. So, this is the type the things actually. Generally, an open well is a thick well actually. So, if you take the well basic is the thickness may vary, for example 0.5 to 0.75 meters. So, generally in the houses, whatever wells we construct the olden days actually mostly are in the fields for yield, for giving the water to the agriculture point of view. There whatever open wells which we construct, these are all the basic things which we talk. But how the technically speaking, how open wells will be, the open wells you can classify into two types. One is called as shallow well, the other one is called as deep well. Shallow well means only just the percolated portion. What is wherever the pervious formation is there, into that the well is percolating. That's all. That means it won't go much deeper actually. It is only in the pervious soil surface it will be there, and then from there it extracts water. So, that is what we call it as shallow well. Whereas deep well means it naturally rests on some impervious layer. This motor layer means not highly impervious layer, some impervious layer if it is there. So, naturally it rests on the impervious layer and we make a hole to the impervious layer actually, and then we draw water from this pervious portion. So, this type of wells are called deep wells. So, one is shallow well, deep well. In both the cases, the depth is not large actually. Maximum it can go up to is 60 feet, 50 feet. That's all maximum. Only thing is, one is directly resting into the pervious formation. The other one is resting on a mortar layer, an impervious layer, and then penetrating. A hole is made in the impervious layer, and then from the bottom portion we will extract the water. So these are the two types of wells actually which we have. And if you go and see in the houses actually, in the right now most of the people are depending on the municipal water supply only. So many people may not have these wells actually. Previously, wherever the water table is nearer to the ground, especially in sandy soils, especially in coastal areas, we see these open wells more. So where we can get groundwater, less than 10 feet depth we can get groundwater. So such type of sandy belts wherever are there, this we can, open wells are predominantly seen actually, right? And how to get an yield from an open well, right? Open well, how to get the discharge from an open well? To get the discharge from an open well, there are only two methods are there. One is constant level pumping test. The other one is recuperation test. So what are the two tests actually? Constant level pumping test. Second one is recuperation test. What for these two methods are used? To get the discharge, to arrive at the yield from an open well, because any well is finally, the purpose is only to get the groundwater outside. So how much groundwater you can get outside? What is the discharge that you are going to get outside? That is what the functionality. So if I see that in the constant level pumping test, kindly listen carefully. What is the main crux of the entire test? For example, now we have basically this a well is constructed in a pervious formation. So this is the pervious formation. We have constructed a well actually, and now this is the static water level we have. Figure only, please see it. Then actually what we are doing, we are trying to pump the water, right? How we are pumping, that is the question. This constant level pumping test, what is the meaning of that? First thing what we do is, we start pumping. So when the moment you start pumping, naturally the water level, what will happen? Slowly at the well, the water level decreases, and then naturally it will be basically a cone of depression is there. That is how the drawdown curve is there. So this is the depression head. So what we will do in the test is, initially we pump, the depression head is H. Now we regulate the speed of the pump. We regulate the speed of the pump such that this H remains as constant. This H remains as constant. When that will happen, whatever water enters from this aquifer into the well, that is being drawn outside. In such a case, this head remains as constant. So you need to maintain this H as constant. So speed of the pump is so adjusted to maintain constant head. What is that constant head? Is this H. Right? If you are able to do that, then it will be continuously at that level only. That's it. Then what you need to do, whatever water that is pumped outside, you allow it through a channel and put a V notch or rectangular notch or whatever notch you want to keep it, and measure the discharge. So whatever it is coming out, that you can measure it with the help of a V notch, and that is what it will give you the yield of the pump, the well. So what I have done in the test, initially the water level is, some water level is there. Then what I have done, started pumping. We get the depression head of H. In order to maintain the depression head H, the speed of the pump is regulated. So how basically this H is remaining as constant. So after regulation, whatever water that comes out from the well, right, that is being channelized into a small channel, and there a V notch is kept, and you measure the discharge through the V notch. You know how to measure discharge through a V notch. That is what the entire thing is. Right? You run the pump actually for 1 hour. So in 1 hour, how much you have collected actually outside, through the V notch, that you measure it, that gives you the discharge from the well actually. So we know the Darcy's equation. What is the Darcy's equation? Q is equal to KIA. So now actually Ka into H by L. Can I write or like that? Because I is equal to hydraulic gradient is equal to H by L actually. So if I put I is equal to H by L, and then this is what we are writing it. Then actually K by L into HA instead of then this. K by L is what we call it as C. So the C is called as percolation intensity coefficient, and area, cross-sectional area of flow into the well at its base, H is the depression head. So naturally you can use directly Q is equal to some C into A into H. If you use it, then directly you can find out the yield. What is C is equal to? It is nothing but it is K by L actually. So this is what is the basic thing actually. So now because of the well is only in the pervious formation, because of that naturally what is this ellipse like thing which I heard? It's not ellipse, it is a circle actually. So this circle, what it represents actually, because of the pumping actually, because this soil, entire soil is such that it is loose soil, then naturally what will happen is a cavity is formed at the base. So because of the cavity formation, instead of only which we take A is only this is A is equal to pi by 4 into D square. That is what we will do it actually. D is the diameter of the well. So instead of taking A, you need to take some extra area also, because of the cavity formation at the bottom, then it draws water from a larger area. So that's why it is 4 by 3 times the actual cross-sectional area. So A is equal to 4 by 3 times pi by 4 into D square. So that is what you should remember. Apart from that, everything is fine. So now what is the fundamental thing I mentioned in this constant level pumping test? First one is depression head H is maintained as constant. How depression head H is maintained as constant? By regulating the speed of the pump in such a way, always this depression head remains as constant. At that case, apply the Darcy's law actually. Q is equal to KIA, where I is equal to H by L. Writing that K by L is what we call it as percolation intensity coefficient. But the area A is not just area of the well, but you need to take a little bit larger because of the cavity formation at the bottom. So that's why it is 4 by 3 times area. Then naturally the thing is, suppose as the pumping is, as the discharge increases, what will happen to the head actually? Now area remains a constant actually. See, percolation intensity coefficient constant. So Q is proportional to finally what actually? H. So when Q is proportional to H, as basically Q is increasing, H is what is happening to H? H is increasing. H is increasing means what is happening? The velocity actually, if you see it naturally, more and more velocity will be there for the flow. When more and more velocity is there is a problem that at some point of time, suppose if you want to get more and more discharge, so naturally the depression head is going down and down and down, then what will happen at certain point actually, along with water, the soil particles also gets dislodged and they also move up actually. So that if that case happens, then you are not drawing only water but soil also. So that should not happen. That is why there is one head which we call it as critical depression head. So that means you can start increasing the discharge, but it can, the threshold value of that is the head cannot go beyond that. The head can be basically here, it can be increased or decreased in the well, whatever you call it as. From the water table, it is increasing. From the well point of view, it is decreasing. So whatever it is, it cannot go beyond certain level. So that is what we call it as the critical depression head. So beyond critical depression head, if you start increasing the discharge, what will happen is it dislodges the soil particles also because of the more velocity. So naturally but along with water, soil also comes out. That's what I described here actually. If you see it here, normally the head value can go only up to a limit. So discharge you can increase, but limits are there. So that's why this critical depression head I will mention, I had mentioned it. Then afterwards, what is the safe yield? Safe yield is nothing but actually whatever the maximum, the safe yield or maximum yield, whatever you, if you call it as the maximum yield, is nothing but at critical depression head, whatever discharge you are getting outside, that is what we call it as maximum yield. Coming to the second method, what I mentioned actually, it is recuperation method. Recuperation, that means on its own it is regaining it. Recuperate, previous one is constant level pumping. So that means the level in the well should be maintained as constant. That is the previous one. How that is maintained? Is maintained by regulating the speed of the pump. That is the first thing. Then in this method, recuperation, that means the well is allowed to recuperate. It has been given some time to regain its level. That is what we call it as recuperation test. Why we need to go for recuperation test? The need for the recuperation test is pumping test. There is one problem actually with the pumping test. What's that problem with the pumping test? In the case of pumping test, maintaining the speed of the pump in such a way that the depression head is constant, that regulation part of the pump is not that simple actually. So that is very difficult actually. So that is why in such a case where there is a difficulty in regulating the speed of the pump, then naturally we will go for the second method, which we call it as recuperation method. So what is this recuperation method? Suppose, now see the figure, concentrate on the figure first. There will be some initial water level. This is AA is nothing but the initial water level. Now what we have done, we start pumping. When we start pumping, naturally what will happen to this level? It goes down, right? We have done it. So now when the pumping is stopped, this is the level. So BB is the level when pumping is stopped, and just we kept quiet. Initially it is the water level. Now we pumped, and then actually we just stopped it. When we stopped pumping, this is the water level. We kept quiet. Then we are observing what is happening. When we are observing what is happening, after a time t, capital T, after a time capital T, we found that the level of water in the well is increased up to cc. Why it increases? Even if the moment you stop pumping, naturally from the surrounding points, the water will enter into the well, so the water level in the well increases. That is what, because groundwater moves. So this is how the water moves. So naturally the water level increases in the thing. So it has gone to cc. In how much time? T hours. So that is the basic thing. That means principle is that we allow the well to recuperate. Based on that, we try to derive an equation. Found it? Initial level is this. We pumped. Then it has gone to some down level. We stopped pumping and we just kept quiet. Automatically now what is happening? Well is recuperating and the water in the well is increasing. It has come to final level is cc. So this is the starting point. With this background, I need to derive an equation for the discharge, for the yield. That is my principle. What I am doing, at some time t, at some time small t, let the water level has come up to, for example, here. The water level has come to here. That means H. from the initial level. If I allow a small time dt, then in that small time dt, it recuperates by an amount dh. It recuperates by an amount dh. So at any time small t, the level of water in the well is this. In small time dt, the level here has come up to here. It has basically decreased by dh because of the recuperation. That is the first thing. Now tell me, what are the things first? AA is the initial water level. BB is the water level when the pumping is stopped, right? Then this is what is called as the depression head. That's all only we have, the first thing, AA to BB. Then what we will, just we kept quiet. Then after time T, it has gone to CC. At that time, what is the depression head? H2. Now what I have done, at any time T, let the depression head is H. In small time dt, it has increased by dh. That's what I have written. Right? Now you see, in a times t, how much it is recuperating? Initially it has come to H1 and this is how it recuperated. So how much this is? H1 minus H. This means this is what we call it as recuperation. Right? So if that is the case, what is the volume in this small strip? What is the volume of water entering in the well? Volume of water entering the well when the head recuperates by dH. Area multiplied by height. So it is rectangular like ADH. This is what I have put. A into DH. Right? First thing. So whatever this, it has to come out from here. So what is the discharge generally? Q is the discharge. What do you mean by Q is the discharge? Q meter cube per second. But this DH recuperation took how much time? This DH recuperation took DT time. From BB to here, it took small t. From BB basically to CC, it took capital T. But from here strip itself, this time is dt. So if Q is the discharge coming out, what is the volume of water that is coming out from here? The volume of water that comes out of the well is equal to Q, this is meter cube per second, into time is how much? Into dt seconds. That is the second equation. So there are two equations. What is the first equation? We consider at any time t, the level of water is this. In a small time dt, the well has recouped by this amount. So if that is the case, what is the volume? Volume is equal to area into height. This is one equation. What is the second equation? Whatever water that has recuperated has to come out. If Q is the discharge and this Q is in meter cube per second, in how much time it recuperated? dt. So these are the two equations. If you equate these two and then analyze it, you get the solution. Before going further, we know that Q is equal to, right? Already we have done previously. What that we have done actually, Q is equal to is proportional to H. Q is equal to some K into H. Right? Where K is a constant depending on the soil. So dV is equal to, instead of Q, if you put this, it is KH into dt. So now there are two things. One is KH into dt, one is ADH. Equating these two actually, then we get basic KH dt is equal to minus ADH. Why minus sign actually? H decreases as T increases. H, if you see it actually, as the time increases, what is happening to the H depression head? It is recuperating. That is what I have shown. Now the integration. What are the limits actually? There are two things, variables here. For time, what is the basic thing actually? Time is varying between here, this is the starting point, this is time is equal to 0, and what is the end point here? T is equal to T. That is the thing. So what is the limits for T? T is equal to 0 to T. This is the time. Similarly, what is the head limits actually? H limits actually, if you take it, the head initial thing is how much actually? It is H1 to, how much is the final thing actually? H2. So the head basically varies between H1 and H2. Time varies from 0 to capital T. So knowing that, I have put exactly the same thing and trying to integrate the equation. K by A into, because this A on that side I have taken, I have put K by A into dt is equal to dH by H. dH by H is nothing but log base EH actually, and dt is T. K by A, T is equal to log base E H1 by H2. You may be thinking H2 by H1, but because of this minus sign, it is H1 by H2. So finally, K by A into T is equal to log base E H1 by H2, and that we can, or K by A is equal to 1 by T into log base E H1 by H2. So multiply this by 2.303 so that the base will be log 10. So that is what we have done. So finally, we got an equation such that K by A is equal to 2.03 divided by T into log base 10 H1 by H2. This is the final equation as far as the recuperation test is concerned. So normally you can calculate K by A, or generally what is known a thing is K by A is known generally, and this is called as, what is K by A is called as, it is specific capacity. So recuperation test, what it will give actually to you? So initial water level is this. Then when pumping is stopped, this is the level. So for us, AA is not there at all. Now for us is only, this is the point actually. From here, when the pumping is stopped, then it starts recuperating, and at time capital T, it recuperates. And in order to calculate that, what we have done, we have taken what this is the level when actually in a time small t. So in a small time dt, it recuperates by dH. That's what we have taken. So now what is the volume of water here is A into dH is the volume of water entering the well. What is the volume of leaving the well? Q into dt. Equating these two, actually Q is equal to KH. So equating that, we got the solution. That solution is 2 by 2.303 divided by T into log base 10 H1 by H2. In this, K by A is called as specific capacity. Suppose without doing the recuperation test also, the rough values of K by A can be taken. What are the rough values for K by A is, K by A is equal to 0.25 for clay, 0.5 for fine sand, 1 for coarse sand. These three is enough for you. Remember that in the absence of data, K by A can be this value, this value, this value, depending on the soil actually. What is the unit of K by A? K by A is nothing but K is, it is meter cube per hour per square meter area, right, under unit depression head. So kindly remember that. Knowing the value of K by A, we can find out what is Q. Q can be calculated, basically it is as KH. So it is equal to K by A into AH. So what is K by A? So this is all equal to K by A. K by A into H. So this is another method of finding out the discharge from an open well. So there are two tests. One is constant level pumping test. The other one is recuperation test. So this completes to me again another lecture regarding the open wells which we have talked about. So the open wells classification, shallow wells, deep wells, what are they? We defined it. Then actually how to find the yield of an open well by constant level pumping test and also basically by recuperation test, and some problems we have solved. And kindly note that we acknowledge these two books are the main sources for me to take out these lessons. So kindly please read these two textbooks for the entire content which we have taken in this are from these two textbooks.
Like, share and subscribe. Hit the bell icon for more updates.